Hi, hello everyone. Very good evening, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the session, IIT Kanpur Previous Year Questions Series. Today, we will be solving the previous IIT Kanpur conducted questions of programming subject, right? We know IIT Kanpur has conducted in the 2001, 2007 and 2015 years earlier, of course even some more years earlier, but today we will be trying to solve these 3-year questions. Okay, so before I start, I request everyone to please join the session quickly and mark your presence. Sahil Malik, good evening. Those who have joined the session, guys, quickly invite your friends also for this session. So we will be solving IIT Kanpur previous year questions. Hurry up. Soon after you join, we will start the questionnaire. This is quick brief about me. I am Satya with 14 plus years of teaching experience, mentored more than 30,000 students. I am qualified in GATE, UGC NET, SET and also certified by Cisco. Priyanka Kumari, good evening. Ashwani, good evening. How are you all doing? Great. So guys, whoever have joined the session, please do like the session, share to all your friends and also subscribe to our BEP BYJU'S Exam Prep GATE channel. Okay, now let us start the questionnaire with the first question on your screen. So 2015 GATE question is here. Consider the following C program. We have the program given with for loop and cases. The question is the number of times printf statement is executed. So guys, everybody give your answers for this question quickly. So how many times the printf statement executes? Guys, this question we have even solved in the other sessions also by me, right? So what is the answer for this? It's a NEAT question, numerical answer type. Sahil, Priyanka, Ashwani, Tushar and everyone, what is the answer? First of all, am I visible and audible to everybody? Okay. So what is the answer for this question? Let us solve. We are given 3 variables I, j, k, initialized to 0. J is equal to, we have some arithmetic expression here. So let us solve it. First 2 into 3 will be performed, which is 6. Then 6 divided by 4, when the numerator is integer, denominator is integer, we know we will get only integer. So 6 divided by 4 quotient would be 1, and then 2.0 divided by 5 will be performed. This will give 0.4 because 2 is given as represented as 2.0. So you will get the factorial fractional number or float number as result. Then 8 divided by 4, that is equal to 2. Now you have to add all these. 1 plus 0.4 plus 2. 8 divided by 5, sorry, right. Now it would be 1. 8 divided by 5 would be 1. So this would be 2.4, but that 2.4 we are assigning to j, right? J is what kind of variable? Integer variable. So what would be j value? J value would be 2. Now k minus is equal to minus minus j. That means k equals to k minus 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 j. What is minus minus j? J becomes 1. What is k? 0. So k is equal to 0 minus 1, that is minus 1. So k value is minus 1. Now for I equal to 0, I less than 5, I plus plus. So this program executes for 5 times. When I is equal to 0, when I is equal to 1, when I is equal to 2, when I is equal to 3, when I is equal to 4. When I becomes 5, 5 less than 5 will be false. So there the loop ends. Now in switch, what we have? I plus k. So 0 plus minus 1, that is minus 1. So do we have case minus 1? No. So what gets executed? Default printf gets executed. Only one printf gets executed. Next, I becomes 1. 1 plus minus 1, that is 0. So do we have case 0? No. So again default printf gets executed one time. Now I becomes 2. 2 plus minus 1, that is 1. So do we have case 1? Yes. But observe, there is no break statement after case 1. Hence until break or until end, the statements gets executed. So printf of case 2, printf of case 3, printf of default also executes. So printf, 3 printfs gets executed. Then I becomes 3. 3 plus minus 1, that is 2. We have case 2? Yes. But after case 2 there is no break. So again 3 times printf gets executed. Then I becomes 4. 4 plus minus 1, that is 3. Do we have case 3? Yes. But after case 3 do we have break? No. So 2 times printf gets executed. So total number of times printf executes, if you see here 1 time, here 2, here second time, here 3 times means 5, here 3 times means 8, here 2 times means 10. So total number of times printf gets executed is 10 times, right? So the answer is 10. Everyone, did you understand? Any doubts? Okay, let us proceed to next question. Good Sahil. Next question. Before that, I request all the students to share the session information, invite your friends for this session, and also please do like the session. Here is the second question of the day, which is the 2015 GATE question again. Consider the following C program. We have certain code, and finally what is the output of the program. So we are supposed to find out the output. So guys, I am giving 1 minute time. Quickly solve and tell me what is the output. What we are printing, that would be the output. What we are printing? X value we are printing. So what is X? X is equal to X plus F1 plus F2 plus F3 plus F2. So the return values of these functions will be added with X value. Quick. You have more 30 seconds time to answer this question. Hi Ankit. Ankit Venture. Okay, Surya says 179 will be printed. Okay, fine Surya. If you observe this program, we have one global variable X. So X is equal to 10, that is the global variable defined outside all the functions, and we have one local variable X. X is equal to 1 inside the main, and in F1 we have X, in F2 we have X, right? So the code is F1 plus F2 plus F3 plus F2. So the code is X is equal to X plus F1 plus F2 plus F3 plus F2. Now X is what the main function X value we have to take. So that is 1 plus execute F1. What is F1? In F1 we have 25. We have 25. So X is equal to 25. Now what is there? X plus plus return X. So here you have to understand, we are not writing it as return X plus plus. Some students might think it return first 25, then it will be incremented. When that happens, if you write return X plus plus, then 25 is returned. After returning 25, increment happens. But here what happens? Here X plus plus, that means X value is incremented before returning only. Then you return that value. So 26 will be returned. Okay, we do not have written X plus plus. If you have written X plus plus, then 25 would have been returned. Okay, then F2. In F2 we have another X, that is a static variable. So its values will be preserved between the calls. It is initialized to 50, and we have again same X plus plus return X. So first X value is incremented, that becomes 51. Then return X, so 51 gets returned. Now F3. In F3 it is directly given x is equal to x into 10, but we do not have any x in F3 declared. Then which x will be accessed here? Main function x, or f1x, or f2x, or global x? Global x value will be taken. So we have a global x value, that is 10. So this is what taken by F3. So this would be 10 into 10, that is 100. Which x will be modified? Global x will be modified. Then return that x. So 100 gets returned, plus F2 again. So when you call F2 again, the old x value which is updated to 51, that still exists. Now x plus plus, so it becomes 52. Return x, so it will be returning 52. So now sum up all. This is 29, 30, 80 plus 100 plus 50, 27, 28, 30, 80 plus 50, 130. Okay. This will be 230. So the main function x is becoming 230, and what we are printing? That main function x. So what would be the output? 230 would be the output. Got it? Whoever are watching the session, please do invite your friends by sharing the session. Am I clear so far? Good. Let's proceed to next question. Here is the next question, guys. Consider the following recursive C function. If n less than 1, return get of n minus 1, get of n minus 3, print n. Okay. If get of 6 function is being called in main, then how many times will the get function be invoked before returning to the main? Very good question. So guys, do it. If you call this get of 6, total how many times this get function is invoked? You have 1 minute time. Tushar, Sahil, Ankit, Patel, Surya, AB de Villiers, and everyone. I hope you are working on it. Quick. Okay. Tushar says 15 times. All right. Sahil Malik 25 times. Okay. So basically get of n is calling get of n minus 1, get of n minus 3. When n less than 1, it return. So until n less than 1, we have to draw the recursive tree. Yes, de Villiers. So first, get of 6, n is equal to 6, it is not less than 1, so it will call get of n minus 1, get of n minus 3. Now here n is equal to 5, here n is equal to 3, it is not less than 1, so it will call get of 5 minus 1, 4, get of 5 minus 3, 2. This will call get of 2, get of 0. 0 less than 1, so it return. It returned to what? Not the main. It returned the control to get of 3. That's it. Now get of 4 will call get of 3, get of 1. 1 less than 1, false. So this also execute. AB de Villiers, you will not get bigger value of n. Don't worry. Now get of 3 will call get of 2 and get of 0. So this will not execute. Now get of 1 will call get of 1 minus 1, 0, 1 minus 3, minus 2. Get of 2 will call get of 1, get of 2 minus 3, minus 1. Get of 1 will call get of 0, get of minus 2. Now if you observe, we have overlapping of subproblems. Get of 2 is here, and also here. So this complete recursive call takes place even here also, isn't it? So just count how many times it is calling get of 0. Let me count. Get of 0, get of minus 2, 2 times. By the way, get of 0 will again in turn call get of minus 1, get of minus 3. So here 1, 2, 3, 4, 5, 6, 7 times get of 2 is calling the get function. So here 7 times. Now get of 0. Okay, wait. Get of 0, 0 less than 1. So it won't be calling it again, right? So now let us count fresh. So get of 0 one time, get of minus 2 one time, second time, get of 1, get of minus 1, get of 2. So here 5 times get of 2 is calling, so here 5 times, here also 5 times. Okay, and now let me count. Get of 2 3, get of 2 means 15 times, then get of 3 16, then get of 1 again here 17, get of 0 18, get of minus 2 19, get of 0 20, get of 3 21, get of 4 22, get of 5 23, get of 6 24, and did we miss any? Somewhere we missed one. What is that? Yeah, here we have 25. So total 25 times the get of n function will be invoked. Total 21 times this get of n function is invoked. That is what the question. How many times this get of n function is invoked? How many times? 21 times. It's 25 times. So the answer is 25. Surya, 1 less than 1 is false, no? 1 less than 1 is false. So return will not happen. 1 greater than 1 false, 1 less than 1 false, 1 equal to 1 is true. So it will call get of 0, get of minus 2. Get of 0, yes, return. Get of minus 2, return. Tushar, yeah, mistake everyone will do. Even while doing this, I also first went on with get of 0. So it happens, but we have to be very attentive. This is such a easy question, but we have to be very attentive, otherwise we will be doing mistake. Okay, fine. Any doubts? Clear? Great. Next, 2007 gate question is here. Consider the following C function: int f of int n, static int r is equal to 0, static variable we have. Okay, if n less than or equal to 0, return 1. If n greater than 3, r equal to n, return f of n minus 2 plus 2, and overall return f of n minus 1 plus r. So what is the value of f of 5? Yes, guys, recursion questions seems to be simple but time taking. So for improving the speed and accuracy, practice is what needed. Yes, Surya. So guys, quickly solve this question. It is 2007 gate question on your screen. We are calling f of 5 first. So n is equal to 5. static variable, so it would be there throughout the program execution, so I am marking it separately. If n less than or equal to 0, 5 less than or equal to 0, no. If n greater than 3, yes, 5 greater than 3, so r is equal to n, so r becomes 5. Return f of n minus 2, 5 minus 2, 3 plus 2, right? Now what is f of 3? N is equal to 3. 3 less than or equal to 0, false. 3 greater than 3 also false. So it return what? F of n minus 1, 3 minus 1, 2 plus r. What is r? 5. Now f of 2, 2 less than or equal to 0, false. 2 greater than 3, false. So it return f of n minus 1, f of 1 plus r. F of 1 is called n is equal to 1, so 1 less than or equal to 0, false. 1 greater than 3, false. So it would be f of 0 plus r. Now n is equal to 0. If n less than or equal to 0, 0 less than or equal to 0, false. So it return what? 1. So now you add all this. It is 1 plus 5 plus 5 plus 5 plus 2. This is 18. So finally, what is the return value of f of 5? 18. That means what is f of 0? F of 0 is 1. That is added to 5 and we are getting that as return value for f of 1, that is 6. That is added to f of 5 and we are getting f of 2 as 11. That is added to 5 and we are getting f of 3 as 16. Now f of 5 is equal to f of 3 plus 2, so that is 16 plus 2, 18. That is how it is 18. Am I clear? Any doubts? Please feel free to ask. And all the students whoever have joined the session, quickly like the session, share to all your friends and subscribe to our BYJU'S Exam Prep GATE channel. Okay, let's proceed to next question, dear friends. Here is the next question, again 2007 GATE question. Consider the following segment of C code. Int j comma n, j equal to 1, while j less than or equal to n, j is equal to j into 2. The number of comparisons made in the execution of the loop for any n greater than 0 is log n base 2, 1 is minus 1. Just give me a moment. Yeah, 1 is minus 1, 1 is plus 1. Log n base 2 minus 1, log n, log n, log n base 2 plus 1. Patel Parth is okay. So you think answer is C. Fine. Fine, Patel. Okay. What about others? Sahil Malik, option D, log n base 2 plus 1. All right. Tushar, option D. Okay. Okay. Please pay attention. Initially j is equal to 1. Now 1 less than or equal to n? True. Then j becomes 1 into 2, 2. 2 less than or equal to n? True. Then j becomes 4. Then 8. Then 16. Then 32. So if you observe, until k is greater than or equal to greater than n, this will execute. Whenever k is less greater than n, this will fall. So if you observe, initially j is 1, that is, we can say it as 2 power 0. This as 2 power 1. 2 square, 2 cube, 2 power 4, 2 raised to 5. Let us say until some two raised to k, it execute. K times it is executing. So 2 raised to k is less than or equal to n. That's why even the kth time also it is executing. If so, what is k? Log n base 2. So log n base 2 times it is executing. But how the compiler know that the next time I should not execute? It is making the comparison, isn't it? That means this is all log n times. Log n times the condition is becoming true. This is log n plus 1th time. When the j value becomes greater than 1, that is log n plus 1th time. So log n base 2 times the condition is true, plus 1th time the condition is false. There it ends. So the question is, how many comparisons we are doing? As you do last comparison also, you realize that the condition is false. Without comparing, how the compiler know? So the last comparison also happens, isn't it? So the total number of comparisons are log n base 2 plus 1. Patel Parth, do you get it? Very good. Tushar, Priyanka, Surya, Sahil Malik, very good. Great. Next question. Another 2015 GATE question. What is the output of the following C code? Assume that the address of X is 2000 in decimal and an integer requires 4 bytes of memory. Okay. We have unsigned int x of 43, that is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now print x plus 3 star of x plus 3 star of x plus 2 plus 3. So what is the answer for this question? Even this question we have solved multiple times. In the other sessions, we solved it multiple times. So if you have attended those sessions, you can easily give the answer. Even the solving of this question is also simple. Okay, Surya, Tushar, Priyanka with option A. What about others? Patel, A.B. de Villiers. Sahil, okay, Sahil is giving option A, or okay, right. We have a two-dimensional array with 4 rows, 3 columns. Values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12. These are the values. It's given the base address is 2000. So this address is 2000. And the default would be row major order. And every integer takes 4 bytes. So this would be of 2004. The address would be, this address would be 2008. Its address is 2012, 2016, 20, 24, 28, 32, 40, sorry, 36, 40 and 44. Okay. Now first, this array name is X. So X itself is the base address. X itself, the array name itself is the base address. And this is the first row of it. So that is X plus 0. This is the second row of it, third row of it, fourth row of it. So X plus 0 means 2000. X plus 1 means 2012. X plus 2, 2024. X plus 3, 2036. Now, what is X plus 3? 2036. That is the address of third row. That is X of 3 row. Now star of X plus 3. Now it is a pointer pointing to single element or total array. It is now pointer to whole array. So even star of X plus 3 also gives the same. So remember, in two-dimensional arrays, X plus I is equal to star of X plus I, that would be address of X of I. That means that ith row base address, ith row base address you will be getting. Okay. So star of X plus I also will give the ith row, that is the third row base address. Now star of X plus 2, second row base address, that is 2024 plus 3. Here 3 means what? Next third element address. It's not just a constant 3 addition. This is a pointer arithmetic. This is pointer arithmetic. Pointer addition means address addition. So this is giving next third element address after 2024, the third element address. So this is the first element address, this is the second element address, this is the third element address. As it is a simple, we have calculated first, second, third. When it is a big array, how you calculate? That is 3 multiplied by size of one element. So that is 2024 plus 3 to 4, that is 2036. So what all prints? The same 2036. So option A is the correct answer. Okay, got it? Any doubts? Fine. Next question is here. Again 2015 GATE question. Consider the following function written in the C programming language. Void foo of char star a if star a and star a not equal to space. Foo of a plus 1, put char of star a. What is the meaning of star a? The value at this, if it is pointing to if non-null, if it is pointing to some valid character, not null character. Surya, both give the base address only. Surya, if it is a one-dimensional array, x and x are same. If it is a two-dimensional array, x is the base address and x means you can say that is the first row base address particularly, or multi-dimensional array. Okay. Remember, every array is a pointer. Every one-dimensional array is equivalent to pointer. And what is if star a not equal to space? That means the character where it is pointing, if it is not space, then only this recursion takes place. So the given input is A, B, C, D space E, F, G, H. We know by default there will be null character. This is not 10, null character. Now, the output of the above function on input so and so is. First, A is pointing on the first character. Is it non-null? True. Is it not space? True. So, foo of A plus 1. So, it is like this. Foo of A, B, C, D, E, F, G, H. So, A is pointing here. It is non-null, non-space. So, foo of A plus 1. That means it in turn recursively call the same function with B, C, D, E, F, G, H. Now A points to B, capital B. It is non-null, not space. So it recursively call C, D space E, F, G, H with A pointing at C. It is non-null, non-space. So this recursively call foo of D, E, F, G, H with A at D. It recursively call foo of space E, F, G, H. So pointer is at space. Now is it non-null? True. Is it non-space? False. So true and false becomes false. There it written, means this recursion ends. Now after recursive call, see, this is a head recursion. We have one statement pending in every recursive function, that is put char of star A, value at A, character at A should be printed. So it print D, then it return character at A, print C, return print B, return print A, return to the main. So finally what is the output we are getting? D, C, B, A. If at all it is a tail recursion, then you would have get A, B, C, D. If there is no space between A, B, C, D and E, F, G, H, then you will be getting, for the head recursion, H, G, F, E, D, C, B, A. For the tail recursion, A, B, C, D, E, F, G, H, when there is no space. As we have space here, we get only till D, C, B, A. Got it? Any doubts? Please respond. Do you have any doubts? Chetan, yeah, playlist would be prepared. There is a master playlist, you would get it. Fine. Let's proceed to next question. One more 2015 GATE question is here. Consider the following C function. Int fun of int n, if x is equal to 1, int x is equal to 1 comma k, if n is equal to 1, return x. For k equal to 1, k less than n plus k, x is equal to x plus fun of k into fun of n minus k. Finally return x. So the return value of fun of 5 is, it's one of my favorite questions, very good question this is. So guys, quickly solve this and give your answers in the chat box. Quick. Okay, so first we are calling it with fun of 5. Fun of 5, n is equal to 5. So here x is created, x is equal to 1, n is not 1, so for loop execute from where to where, k1 to n. So when k is equal to 1, when k is equal to 2, when k is equal to 3, when k is equal to 4. 4 times this loop executes. Now what is when k is equal to 1? X is equal to x plus 1 plus fun of k, that is 1, multiplied with fun of n minus k, 5 minus 1, 4. So we don't know what is that fun of 4, right? So we want that fun of 4 first. So fun of 4, n is equal to 4, x is again created as 1. Now loop executes 3 times, when k is equal to 1, when k is equal to 2, when k is equal to 3. When k equal to 1, it is again x is equal to 1 plus fun of k multiplied with fun of n minus k. So we don't know what is this fun of 3, right? Now what is fun of 3? n is equal to 3, again x is created. Now loop executes for 2 times, when k is 1, k is 2. When k is 1, x is equal to x plus fun of k multiplied with fun of n minus k. Fun of 2, again we want, if you need to trace it, n is 2, x is created as 1. So this loop execute only 1 time, that is when k is 1. Now when k is 1, x is equal to x plus fun of k multiplied with fun of n minus k, 2 minus 1, that is again 1. What is fun of 1? N is equal to 1. When n is equal to 1, return x. So it return x. So what it returns? 1. So fun of 1 is equal to 1. So bring that to fun of 2. So this is 1 plus 1 multiplied by 1, that is 1 plus 1, 2. So x is equal to 2. So fun of 2 is equal to 2. Bring that to fun of 3. Now when k is equal to 1, this is x is equal to 1 plus fun of 1 is 1, fun of 2 is 2. So this is 1 plus 2, 3. Wait, we have one more loop to execute here. X is equal to x plus, what is x now? X, change it to 3. 3 plus fun of n multiplied by fun of n minus fun of k multiplied by fun of n minus k. 3 minus 2, 1. 3 plus 2 multiplied by 1, that is 3 plus 2, 5. So x change it to 5. So return x. So what gets returned? 5 gets returned. Bring this 5 to fun of 4, because we are waiting. Now x is equal to 1 plus fun of 1 is 1, fun of 3 is 5. So that is 1 plus 5, 6. This x modified to 6. K becomes 2. 6 plus fun of 2 multiplied by fun of 4 minus 2 is again 2. So this is 6 plus 2 multiplied by 2, 6 plus 4, that is 10. K becomes 3. x value change it to 10, k becomes 3. Now k equal to 3, x is equal to that 10 plus fun of k multiplied with fun of n minus k, 4 minus 3, 1. 10 plus fun of 3 is what? 5 into 1, that is 15. So what is f of 4? Fun of 4, 15, isn't it? So bring this 15 in fun of 5. What was fun of 3 we got? 5. Fun of 2 we got 2. Fun of 1 we got 1. So bring it here. X is equal to 1 plus fun of 1 is 1. Fun of 4 is 15. That is 1 plus 15, 16. Now k becomes 2. 16 plus fun of 2 multiplied by fun of 3. 16 plus 2 into 5, that is 16 plus 10, 26. So x change it to 26. K becomes 3. 26 plus fun of k multiplied by fun of n minus k, 5 minus 3, 2. So this is 26 plus 5 multiplied by 2, 26 plus 10, that is 36. So x change it to 36. Now x is equal to that 36 plus fun of k, 4 multiplied by fun of n minus k, 5 minus 4, 1. This is 36 plus fun of 4, how much we got? 15. Fun of 1 is 1. So that is 36 plus 15, 51. So x modified to 51. Loop ends, return x. So return 51. So what is the return value of fun of 5? 51. The given question is very simple question, very small question, but this much solution we have to do. So we should solve this kind of questions as much as possible. Then our speed improves, our accuracy improves, our understanding towards this recursion improves. Very good, Sayal, Tushar. Everybody, do you people understand? Any doubts? Yep. Good, Patel, Priyanka. Surya. Sayal, yeah. Sayal, yes, recursion is the most expected topic from programming and data structures. Most expected topic. We can say for sure topic. Sure shot. Maximum you don't find a question paper without recursion question. Fine, guys. I'll give 2 questions as homework for you. Do them and give your answers in the comment box. Okay. So this is 2015 question homework. And one more 2015 question. So please give your answers in the comment section after you solve them. That's it. This is my Telegram group link, CS by Satya Narayana, and my Instagram group link, Satya_CS group. Please follow me on Instagram and Telegram. And guys, I have started a practice mission where I will be giving a question every day. In my Telegram group and Instagram group, I will be posting a question from 5 subjects, any of the 5 subjects I teach: CO, CN, OS, programming data structures, algorithms. Okay, so every day you will get a question. In this way, till December, I'll assure you will get 300 plus questions, and new questions you will be getting, not previous year questions. 300 new questions you will be getting. Where? In my Telegram group and Instagram group. So if you have not joined yet, please do join my group and follow me, so that you will get these new questions. And as it is a student community, student forum, you can discuss all your doubts with your peer students, get your doubts clarified. Also, you will be getting these PDFs, class PDFs, and any other guidance also you will get through this Telegram group and Instagram group. So hopefully you join my Telegram group and Instagram group and join the practice mission. See you in the next session, guys. Thank you so much for joining the session. Before you leave, don't forget to like the session, share it, and subscribe to our BYJU'S Exam Prep GATE channel. Thank you so much for joining the session. See you in the next session. Till then, have a great time. Take care. Good night, everyone. Bye-bye.